Hi, everybody. Thank you for having me, Paul, Kelly, everybody. We're Trukera Medical, and we want to help you see better faster. We come from a long line of ocular surface dry eye companies. We originally were OcuSense, started in around 2003, and quickly became Tear Lab soon after, with the idea that there'd be a whole bunch of dry eye medications on the market, and there'd be biomarkers that would need to differentiate between different etiologies of the 10 or 15 different drugs that would be on the market. As that has not necessarily come to fruition, we decided to look around and look at where our strengths are, and are now changing and rebranding the company as Trukera because we have a real focus on the cornea and corneal health. And there's a lot of stuff that we're working on that I'm very excited to tell you about, but I can't tell you about today because they're not ready. But one last thing before we go, one more time, we're going to talk about osmolarity because we've done a lot of work on trying to fix some of the problems that we had with our genuine system, and we think making the best osmometer that's ever been, and we're really proud of what we've done. There's been a lot of engineering to go into our new ScoutPro, and I'll tell you a little bit about it today, but as Dr. Karapecki mentioned, any new diagnostic, you have to understand why it matters. And osmolarity matters because there's a primary toxicity onto the ocular surface when there's a hyperosmolar tear film. You have to bring the number down. You have to fix it, in my opinion. Osmolarity is very well correlated with cytokines. Some people may know this. There's a Vandermeed study in 2012 that showed all these pro-inflammatory cytokines, largely coming from the epithelium itself, go up as osmolarity goes up. In addition, meibomian gland disease, especially just meibomian gland disease, if you look at the proteomic studies, don't necessarily suggest that there's inflammation associated with it until you get to more advanced disease, where there's also an aqueous component or there is hyperosmolarity associated with it. And you really do need to treat the main etiology. If there's a meibomian gland disease, you have to fix the problem to bring the osmolarity down. If the osmolarity is high and is killing the epithelial cells, and there's cell death and sloughing, and there's associated nerve damage, there'll be this cycle of damage that osmolarity shows, and you have to bring the number down again. And you see it even in vitro. No inflammation in a petri dish, but we can see that raising the osmolarity will cause a pro-inflammatory cascade and apoptosis in those epithelial cells. Interestingly, we did a large prevalence study across general optometry and ophthalmology clinics, and we found about 44% of the people there actually had a hyperosmolar tear film. Once you start getting above 308 milliosmoles, there starts to be cell damage, and you start to have to worry about what's happening on the eye. But most importantly, again, we're trying to help people see better faster, right? That's the whole point. Many people don't ever associate hyperosmolarity and vision, but we all know that when the tear film is unstable, it compromises vision. It's the first refractive interface between air and water, and when from blink to blink that changes, you will get visual instability and you'll lose contrast sensitivity, which, if you're hoping to have people see better, is a really important thing to optimize. So if you're a premium practice and you care about how your patients see, it's very important, in our opinion, to make osmolarity as low as it can be and stabilize it. This is from a study that Dr. Picella showed about a few years ago. On the left, this is the ocular scattering over time of a normal patient with normal osmolarity. On the right, you can see that the scattering due to the tear film alone is essentially equivalent to a cataract. Blink to blink, it can vary that much. And it's amazing we don't think about all that much, but it doesn't really matter what lens you put before or after the tear film. If the tear film is compromised, you're going to have a really hard time optimizing vision. And we see this a lot in the 20/20 patients that are very unhappy, especially post-premium surgery and cataracts. You can actually have significant deviations. We see it in refractive surgery. Dr. Donenfeld showed this data a while ago, where in the elevated osmolarity patients, the uncorrected visual acuity was far worse than the normal osmolarity patients. And even when you're doing your biometry workups before cataract surgery, in the hyperosmolar group, you have these large deviations away from normal. Over 22% of people had over a 1 diopter difference from test to retest. And so when there's a hyperosmolar patient, it really calls into question a lot of the visual interfaces that we are used to looking at. So this is why it matters. Unfortunately, you can't see osmolarity in a slit lamp, so you actually have to measure it. A lot of this data led to the ASCRS saying it was an essential test for pre-op, and when it's uncontrolled ocular surface disease, you should really look to treat it before surgery to achieve optimal outcomes. One of the things that we found over years and years of trying to sell the original Tear Lab is there were a lot of barriers to uptake. There were clinic disruptions because the device was down the hall and people were running the pens back and forth. The multiple osmolarity systems were expensive, and what we wanted to achieve at Trukera was something that was portable, practical, and precise. And I think we did that with our new ScoutPro. It's a lot smaller. It fits all over the practice. It's very simple to teach to text. There's not two pens. Even something that simple makes it a lot easier to deal with, and you get the number a lot faster. We think you can get from sample to answer in about 30 seconds, and that's pretty cool. No more running back and forth and causing minutes of disruption. And a lot of the technology and the innovation that we put into this was to take the entire system that we had before and all that electronics and shrink it down into a handheld. We call it this Verilite technology. It allows us to get collection and analysis in one device. We're really proud of what we've made. We're working through the initial launch right now. It's going pretty well, but one of the things that we found is that unlike a lot of the early data on osmolarity, we're now very confident that we can say it's very precise. ScoutPro has less than 1.5% CV. Out of the factory, I can tell you that we were getting about 0.5% CV. In real-world testing, we were getting plus or minus 2 to 3 milliosmoles, which is the best we've ever done, and we're really excited about that going forward. Not sure how to play the video. I'll hit play, see if this works. You can see the entirety of a test and how fast it is. This is Lorinda, our subject today. And you can see in 10 seconds, all the microfluidics and all the analysis that goes on in the larger system today is now done in a handheld, and you get a number, 14 seconds flat. So this is a really big change for techs, and we've had a lot of techs say that they can't wait to get this, just given how fast the ScoutPro is. And we think it's going to be a game changer for all kinds of different practices, including optometry that is increasingly busy, given how many patients you guys are about to get. So again, thank you again for having me, and we're here with Trukera, and we want to help you guys see better faster. Thank you very much.